Alright, so 19, 200, 1.02 to the 4t equals 1500, so you divide by 200. Okay, and I used rule 1 here. Log base 1.02 of 7.5 equals 4t. And then you multiply by 1/4 on both sides and you get this. And you can use change of base to figure out what that is, and then multiply it by 1/4. And you get 25.4 something. Now here you're trying to isolate the exponential, so you got to divide by 25. Okay, and you get 2.4 equals this. Now you can use rule 1. Log base 1.015 of 2.4 equals the exponent 12t. And then you multiply by 1 over 12 to get rid of the 12 here. And so you get 1 over 12 times this equals t. You can do change of base, right? Just write log 2.4 over log 1.015. And then multiply it by 1 over 12. And it gives you 4.9 something. 21, you got 3 times an exponential equals 12. So get rid of the 3 by dividing by 3. And now you can take the log of both sides, ln, both sides. And when you do that, that means log base e of e to an exponent. And so your answer on the left is just the exponent. Okay, so if you subtract 5, you get this. If you multiply by a -1, it becomes positive 5 and negative ln of t. So there's your exact answer, and there's your approximate answer. Now this one you can go straight to rule 1. You can say log base 2 of 0.3 equals the exponent. And then if you multiply both sides by 10, that gets rid of the dividing by 10. So there's your exact answer. And if you do change of base, you'll get that answer. Now this one you want the 3 to the x plus 1 all by itself. So first you divide by 2. Subtract 5. And now you've got the exponential all by itself. Now you can use rule 1. Log base 3 of 45 equals x plus 1. I could have just taken the log of both sides, but there's many ways you can solve the same problem. Subtract 1, and here's your exact answer, and here's your approximate answer. This one's pretty tricky. This is like that example we had earlier with the e to the 2x and e to the x. If you let w equal the middle term, e to 3 to the 2x, this becomes w squared, w, and 6. It factors, set each factor equal to 0, you get 3 and -2. And then you have to go back and substitute. You have to let 3 equal 3 to the 2x, and you got to let -2 equal 3 to the 2x. Well, 3 to the 1 equals 3 to the 2x. That means 1 equals 2x, so x equals a half. And then this one, you're going to get no real solution if you take the log of both sides. The right hand side simplifies down to something, but the left hand side is the log of a negative number, which you cannot do. There's no real solution for this part. But you do get a legitimate answer of 1/2. Alright, so on this one, if you multiply both sides by 2 to the x, you get 2 to the 2x plus 3 times 2 to the x, and then minus 10. 2 to the x times 10 over 2 to the x is just a minus 10. And everything else gives you this. Now you can factor it, set each factor equal to 0. And when you solve, this one doesn't give you an answer, but that one does. Okay, now this one, I used rule 1. E to the 0 equals 3x plus 1. E to the 0 is just 1. Subtract 1, divide by 3, and you get 0. Okay. Now log base 2 of x plus log base 2 of x minus 3 equals 2. You can bring those two together and multiply them. And now use rule 1. 2 to the 2 equals x squared minus 3. 2 to the 2 is just 4. When you bring 4 over here, it becomes a negative. Those factor. Set each factor equal to 0, and you get 4 and -1. Now 4 works because that gives you a positive number, and that gives you a positive number, but -1 does not. -1 in here gives you a negative number, and you cannot take the log of a negative number. Okay. 62. log x plus log x minus 3 equals 1, so you can bring those together with multiplication and you get x squared minus 3x. And now I used rule 1. 10 to the 1 equals x squared minus 3. So when you subtract 10, you get this. It factors. You set each factor equal to 0. And when you plug a 5 in here, you get a positive number, so 5 is okay. When you plug a negative 2 in here, you get a negative number there, so that does not give you an answer. Okay, now this one, you just use rule 1. 10 to the 9 equals x, so 10 to the 9th, which I think is 1 billion, possibly. You think it's 1 billion or 1 trillion. Alright, so here, you got log plus log equals log plus log. So these two logs come together with multiplication. And same thing here. 5 times the x minus 2 gives you 5x minus 10. And now if you got log base 2 of this equals log base 2 of that, you can take away the logs and they're equal. And then you subtract 5x and divide by negative 2. And notice you can plug a 5 in here and you get positive number every time, so that's okay. Also notice I'm doing these seemingly out of order on the book, but this is the order in which you see them on WebAssign. Alright, so you bring the 2 into the exponent, you bring these two together by multiplying them. And so now you can say this equals that without the log. You can bring everything to one side and factor and you get 4 and 2. If you plug 4 in here, you get a positive. 4 in here, you get a positive, so 4 is okay. Plug a 2 in there, you get a positive. Plug 2 in there, you get a positive, so 2 is okay. Alright, so on this one, you can bring these two together and write them as division. And now you can use rule 1. 1/5 to the 2 equals this. Well, 1/5 to the 2 is 1 over 25 equals this. And now you can just cross multiply, get yourself a new equation. Subtract 25x, subtract 1, divide by negative 24, and you get 13 over 2, which gives you a positive answer for each one, so 13 over 2 is an acceptable answer.